All right. Hello everyone. Let me update the title. Last time, not last time, like 2 days ago, maybe it was yesterday, I can't remember. But I started working on Advent of Code Day 17, got part one done, and part two seemed hard. I didn't really know how to approach it. I've been thinking about it for the last few days. I have not written much code, but I did a little bit of experimentation, and I found out some things. So first, right? If I look at the output of this program, so if I just run it, and right now I've short circuited part zero or part two because I sort of have it hard coded, and that's not really what I want to do. Need to charge my watch here. Um, so, oh, I'm running the wrong thing. Index out of bounds. Oh, well, it would help if I pasted my input, wouldn't it? Hang on. So I think I've kind of gotten an idea of what this program that is my input is doing. Where is my input file? There it is. Whoops. So if I just look at the output of this program, so let's look at what this program outputs. I get this, and there's something I noticed about this sequence of numbers. Um, I'll sort of step through this register thing in a second because there's a couple of things I've noticed, and I'm going to sort of go from there. So first, this starting number. So if I pull up like an Excel file here, some things that I've noticed are if I start with this number, let me yeah. So something specifically I started digging into and noticed was if I look at the sequence of what the value of A is, it's just dividing by 8 every time. And the rest of our machine, other than the A register, operates in octals. That is 0 to 7. And so I don't think this is a coincidence. And so, like, if I do equals blah divided by 8, but then specifically it is floor.math, and I do that, and then I also get the mod. So this equals um, mod number 8, right? And if I do this, you'll see that like I get all the way down to 0, and my last value is 2. And if you so look 7400, right? So let's look at what happens after we do our A division step here. So um like 7, wait, was this it? No, it was it at BST? Yeah, at BST. So 7 4 0, and then the next BST 0. So this BST step is setting the B register that without putting, wait, hang on, something is awry. Where's my output again? Oh no, sorry, this is my output. Sorry. So I'm getting ahead of myself because I'm sort of forgetting what's happening sometimes. So yeah, at the A advanced, so what's happening is this B register is being written. But what I think is happening, because if you look at it, right, let's take a look at that BST step. Note, or not BST step, excuse me, at the remainder. So let's look at the second to last remainder. No, sorry, not second to last. Where's 3? Okay. Um, God, I forgot everything. I had thought through this problem, and sort of what I had come up with is, let me write the numbers beside them. So the last number printed is 5, and then it's 7, and then it's 2, then 4, then 7, 3, 1, 3. Okay. Now, somewhere in this process, B is set to the remainder. And that's actually right at this. Is it BST? Is that operation? Yeah, BST. Because if you look, every BST operation is using register 4, which is a combo register, which is always the value of A. So this B is being set to that. We're then doing an XOR on B with C. Now you'll notice I did something here. So first, let's take out these mod 8s, because there was something I noticed. Is that I thought, like, okay, is this going to have a factor? So notice when I took out the mod 8s, I end up with exactly the same output. So these mod 8s are actually inconsequential. But the reason I'm doing them is because what I'm thinking this is telling me is that, so first, the number of digits is going to be the number of times that I can divide by 8, I believe. Hang on, I am missing a digit here. Yeah, 3, 5, 1, 3, right? So it's the number of times that I can divide by 8 until I reach 0. That's how many digits I have. And this number, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 digits. That means that I need a number that is between, what would it be? Would it be 8 to the 6? This number is 8 to the 1. So at the 0th digit, with one, okay, so at 6, so I have to be able to divide by 8 15 times. So it's somewhere between 8 to the power of 15, which is a big number, to 8 to the power of 16, which, like, these are really, really big numbers. I mean, this is, in order to actually search this range, I would be searching 7 times 8 to the power of 15 values, which, like, 8 to the 15 is already, I mean, this is what, 35 trillion? So I can't brute force this. I just can't. I'm not surprised by it. But what I'm curious about is, and I wanted to test something. So what I'm actually going to do is I'm going to take out this return 0, but instead of doing integer.forMax, I'm going to do integer to 8. And very specifically, I'm curious about something. Let me run this value, and I'm going to print. Where's my? Oh, let me take out my. Let me take this out. Where's my print? Did I not? I did comment out. Oh, right. Okay. So what I was curious was this. So if I do val result, and then let's just real quick do print line result. And I'm just going to keep returning 0 for now. Am I not calling part 2? What's going on? I am not calling part 2. Okay. All right. Not what I wanted. Oh, that's it. because I don't want to check if it's equal to program. What I was curious about was, okay, what am I printing? And it seems like what's happening is this is almost sort of like a hash. The problem is that in this assumption, I'm assuming that register B and C are 0. But what if they're not? And this is where I started to think, like, okay, because if I'm sort of doing a bottom up here, and I look at how the instructions were printing before, and I'll go ahead and print the so I'll print the results again. And again, the point is that I get the same result for I get the same result for A when I do mod 8B. So what this tells me is, like, while I don't know that B and C are 0 here, what I can do is I can do the following. And this has sort of gotten me going down this path. I'm going to pass in the program, but I'm going to do, so let's just do 4. So first I'm just looking at the value of the A register, and I'm going to call this now A reg. And then, and I'm just going to write this in a bit more of a clever way, do 0 dot dot less than 64 dot for each. Bear, do not scratch the door frames. Sorry, my cat. Okay. Oh, right. Okay. So here is the idea that I have. Is register B is going to be I mod 8 4K. Oh, right. Okay. I need to allow that. Well, but I can actually change this to being an int now. But let's just do it the easy way, and I'll just do a long conversion. And I divided by 8. And what I'm going to do is I'm going to say if result.last it equals 0. Let's just see how many results sort of end up mapping to 0. And I'm going to get one of them, and I'm just going to try to search up the next level. And this is just me sort of premise chasing to see if this idea can work. And if it can't, then I have fucking no clue. I'm back to square one, and I've spent a lot of time thinking about this for the last day. This is not really in my wheelhouse because I'm more of like a software app type professor. But yeah, um, oh yeah, this is a list of int. Why is this a problem? Oh, dot get last. What? Okay, whatever. I see what's going on. So we'll just do print line. Not the result, but a reg a colon a reg B colon okay. That's the plan. And so now, and I don't know if the fear I have is what if I'm building bottom to top or top to bottom, but I sort of have an idea of how I want to approach this. Let me comment out this print statement here so I'm not losing it. So basically I'm testing for every A register 0 to 8, and for every, since I know it doesn't matter, like if B and C, the only value that matters is B and C mod 8. Like I can do mod 8 with B and C and I'll get the same result. You know, this print tree, if you look at it, B and C are never greater than 8, and it still produces the same outcome, right? So let's run this. And what I find is I find a bunch of combinations. Is this, wait, is this every no, this isn't every combination, but it's a bunch of combinations where the last value produced is 0. And it seems like whenever A is 5, my last value is 0. So now what I'm curious about is if I do, because A is 5 for all of these, right? For all of these, A is 5. Now, is it something where I do 40 to 48? That is, multiply by 5 and then try this again. And it's going to be where the last result is 0. Something seems amiss here. Oh, wait, no, it's all of the possible combinations go to 0, right? So now I need to find not the last, but actually where the first equals 3. And now it's 47 and 43 seem to give me that. Not all values of 47. Right. Let me do one more step just as a proof of concept. Let's try. Okay, hang on. I need a calculator. 43 times 8, 344. And it's 344 to 352. And I'm looking for 5. Let's try that. And when 346 is in place. Okay, so I think I'm building this up. So now what I want to do is I want to say, okay, target val target equals program.last index. And I'm going to say no, actually, let me do it this way. Output index int. And what I'm going to do is I'm going to pass in, now it's, oh, and I need a reg start long. And what I'm going to do is I'm going to do passing in program.lastIndex and areg start 0. Okay, and now I'm going to turn this into a recursive function. The point is, if the result dot first is equal to program output index, then instead of printing, let's just recurse. I'm going to recurse get part 2 result. If we have a matching thing, then I'm going to return. Do I return? Do I? All right, let's just. What is the recursive step? The recursive step is it's the same program. Output index minus minus areg start. No, it's result times 8. Wait. Oh no, it's program output. Oh wait, I remember now. It's areg. It was 5 times 8. So it's areg times 8. Now I might need to do some. Okay. Index out of bounds. Oh, because I didn't add my base case. But that means I got to my base case. So if output index is less than 0, then return areg start. This function needs to return a long anyway. What? That doesn't make sense. Oh. Areg start plus 8. Okay, now let's do a memo. Of output index to, or int to long, mapping to long, or actually, sorry, here int long, and then no, not that, because that would just do tail recursion. So hash output index to a reg start equals output index dot to long. No, wait, what am I doing? Equals -1. And then if cache contains pair output index reg start, or again, I'm trying to be sort of consistent with how I do this. I know that cache is -1, so that's fine. Did that work? Holy fuck, that worked. I think that worked. I think that worked. No. Answer is too high. What if it's equal to 0? Let me, real quick, I'm going to, I know I can get away with this, so let me see what happens when I do this. I go 1 digit too far. Yeah, this is a fence post, but I'm getting the right answer. So is it, okay, I'm confused about how this base case doesn't seem to do anything. I'm confused about why I'm getting it off by 1. And how changing this number apparently doesn't seem to do anything. Oh wait, what am I was looking at the wrong thing. So if I do, let's try this number. I think is 1 digit smaller. Okay, now I'm not getting the right result. So okay. Wasn't this the number I tried though? Please tell me it's not asking for like what is the smallest number. So I have to find like every combination. What is the lowest? Okay, so now it's a matter of now actually I want this to be return long dot max value. And really this can just be a set now because I'm not actually using okay. Right. Okay. So return long dot max value, and now it needs to be um get the min of all of these. So it would be min of I if result equals that, then would this be it? Nope, because that's long dot max value. Oh, because I'm never returning if out less than long dot max value, return out. Well, now I do want this to be a map since it's not always um and it's going to be if out is less than long dot max value, then we're going to cache areg start to out. Isn't this the same number? It's the same number I had before that said it was wrong. And I'm still getting that off by 1, I realize. Okay, so now let's try 0 again. And let's rerun it. Let's try this number again. I thought I did before. And yeah, that's giving me the wrong first digit. So somehow my first digit is wrong. Somehow like I'm close. But problem is if I do equals -1, right? Wait, no, I'm getting the same result. But then it's saying this isn't right. Like it's saying this is too big. No, I'm not getting the same result. I'm still getting. Hang on. Did I get a different result when I just reran it? I could have sworn I saw like a 7 here. But yeah, saying this is the smallest number. Apparently it's not. I'll try it one more time, but that's not the right answer. Your answer is too high. Okay. Why is it too high? I'm getting the min of, and I'm getting the result. And I'm returning that result. Let me check something here real quick. Come on, I just want the digits. Hang on, I'm running into an Excel precision issue. Mm. That's frustrating. I didn't realize Excel had that short of a decimal limit. Okay. Maybe my calculator doesn't. Invalid input. It does. Okay. Can I get a. What happens if I divide by 8? And I try this number. Okay, so dividing by 8. Let me make sure this is shorter. Dividing by 8 is giving me the same program. So I'm doing something wrong where I'm multiplying by 8 one too many times. Or maybe I shouldn't multiply by 8 the first time. Or maybe I should just ignore the first digit. I don't know what I'm doing wrong. But let me now try this divide by 64. Oh wait, no. Yes. Let's just see what happens. Or I don't think I want that divided by 64. I want this divided by 8. Excuse me? With this result, I get my program. But also with this result, I get my program? Oh, I'm getting an extra 3 here. I'm such an idiot. I didn't even notice that. For some reason, I didn't even notice that I was getting that extra character. I think this is right. Holy fuck, that was difficult. Wow. So I had to take a lot of leaps in logic, a lot of sort of, and this happens. There's always like one or two Advent of Code problems where this happens. So very specifically, what I sort of started to notice was that in so if I go back and I don't know where this off by one's coming from. Like if I do index one, I mean, I'm not going to get, I don't know. Like I'm not understanding what's happening here. If I'm fully honest, right? Um, like somehow something like I'm not getting why this number doesn't matter. Like I need someone to explain to me why this number doesn't seem to have any impact whatsoever. Like why is this doing literally nothing? Seemingly. If I do 0. No, okay, it is doing something. 0, but 0 is not the right number either. Because I'm still getting the 3. So let's try 1. I don't know. I have some kind of problem here where I just have no clue what's going on. Chloe, chill. So like I'm trying to figure out what this number does, if anything. And I'm looking at the result. Okay, so -1, right. So if I do 0, I get the right result. Except no, I don't. My result is different than this number. It's exactly 7 off of this number. Which I don't know why. Yeah, I'm not fully gathering why I need to divide by 8 here. Like I do, obviously. But I guess it's because I've gone one step too far. And so I need to backtrack one. But shouldn't this do the same thing as that? And it's not. I'm somehow losing the 7. So I don't fully get what's going on. But let me take out this print statement. Like I'm getting the right result. I'm sort of tripping up over I guess it's because I need that +7 that gets found here. And maybe that's it. But then I don't need the last digit, so that's why I divide by 8 again. Maybe. Anyway, so how did I get to this point? Very specifically, it was looking at, and let me comment out my print statement. Here, it was sort of noticing a pattern, and for now, for part 2, I'm just going to return 0 because I don't want to cause issues. And the pattern was that clearly what was happening to the A register every time was it was dividing by 8. Like if you divide this number by 8 with integer division, you get this number and then this one. And at the point you do the division, that the B register is being set to the remainder, I think. The B register ends up being the remainder, I think. Yeah, let me remind myself with the smaller numbers. Yeah. So at BST, that at this BST step, this number ends up being the remainder of this number when dividing by 8. It just so happens that the math works out that way, right? And this, so 3 is the remainder divided by 8. 346 divided by 8, so 40 would be 3,200. So 43, that would be remainder 2, BST remainder 2. So, like, I'm confident that aspect is right. But the actual program output isn't going to match that remainder. If you look at what it outputs in part 1, when I use this number right here, it doesn't look like the remainder. Right, because 5 is not the remainder of 2, 7 is not the remainder of 2, or 19. And so my thought was, okay, we have this 5, or we have this remainder here, remainder 3, and then we do an XOR with the literal value 2. We then do a division on C, so C ends up potentially changing. Though it doesn't here, it can. And then we do another B XOR with the literal 7. And then we do an XOR of B and C. And so this is the value that ends up displaying, this 7. So the point is there's some mapping of like the BST number to what gets output that involves having to know what C is and what A is. But that's like 2 equations, and I don't know how to reverse engineer that. Like I spent a lot of time trying to figure out how do I reverse engineer this. And going up the ladder here, I hit points where I'm just like, I don't know how I derive what C was from this, especially with the C division step. When I'm trying to guess what A was to reverse the division, like I run into a problem. Because it's like, okay, it's 2, but then it's times this 2, but then it's plus 3, right? And I don't know where that plus 3 comes from. Well, it comes from the next BST. But I can't figure out what the next BST is until I reverse engineer this whole thing. But then somehow I have to know that C is 1. And it's just like I got stuck on this problem for like an hour or 2. So my idea coming in to start the stream was, hey, let's just search all 64 combinations because I had worked out by that point that B and C only matter mod 8. Like if it's 8 billion and 8, sorry, if it's 8 billion and 3 or it's 3, it results in the same thing for both of them. And I just figured this out sort of playing around with the numbers a little bit and just test it out like, hey, mod 8 of these, does that produce the same result? And it does. So now, because of that, I'm sort of brute force searching 8 times, really 8 cubed values per depth. So in theory, in a worst case, this would be what is a 512. So in a worst case, this would be like 512 to the 15 searches, which is obviously completely untenable. But that's where this exit condition or this iteration condition limits things. because roughly in an ideal case, only about 1/8 of the cases actually go deeper. Again, not an exact number, just an estimate, and sometimes it might be a lot less. So that's where I ended up, and it worked. I think I'm starting to understand why this comes in. It's because for the last iteration, I need to get the number, and if I just stop at 0, I'm assuming that number is a multiple of 8, but there is actually some remainder added to it. So I get that. Bit weird. Maybe my approach isn't the best, but it works. And then it's just, from there it's just okay, plus memoization. So with that, we are in business. Look at that. Look at that. 38 stars. 38 stars and 12 minutes until we do day 20. I'm wide awake, so I'm actually going to do it tonight. All right, I'm going to stop the stream for now, and then I will pick up the stream here in about 12 minutes.